Our Mysterious Universe, page 20. Double stars and clusters. Our sun is a middle-aged star. Scientists believe it will last another 5 billion years or so before it begins to expand into a red giant. Our sun is also a solitary star. Many stars, however, have a companion. These stars are called double stars. Stars are not evenly spread throughout space. They are often observed in clusters. There are two types of clusters, open and globular. Open clusters are loose groups of a few dozen to a few thousand stars. Over time, open clusters break up as the stars drift apart. Globular clusters are bigger and brighter than open clusters. They may contain more than 1 million stars. Because they are among the oldest objects known, astronomers study them to help determine the age of the universe. The oldest known globular clusters are billions of years old. Even though stars are far away, astronomers know much about them. A star's color and brightness can help indicate its temperature and size. Astronomers classify stars into 7 types according to their color. Blue stars are the hottest, followed by white. Cooler stars look yellow, orange, and red. Scientists find out more information, such as the star's chemical composition, by dividing the light coming from the star into a rainbow of color, or spectra. Scientists use a spectrometer or a spectrograph to do this. Measuring space. What units are used to measure the vast distance of space? One measure is the astronomical unit, AU. 1 AU is the distance from the Sun to Earth, or approximately 93 million miles. Another unit of measure is the light year. 1 light year is the distance light can travel in 1 year. Light travels about 186,000 miles per second. So 1 light year is about 6 trillion miles. Galaxies. Almost all the stars we see in the night sky are part of one galaxy, known as the Milky Way. Until the 1920s, astronomers disagreed about whether the Milky Way was the entire universe or if other galaxies existed. The data available then could be used to back up their hypothesis. Edwin Hubble, an American astronomer, used the most powerful telescope of his time to gather data about the Andromeda Nebula. He discovered it was too far away to be part of the Milky Way. This meant that the universe extended beyond our galaxy. Within a few years, astronomers recognized that the universe was made up of many galaxies, including the Andromeda Galaxy. Hubble Space Telescope. High above Earth's surface is the Hubble Space Telescope. This is an unstaffed observatory, named after Edwin Hubble, was launched in 1990. The telescope is powered by solar panels and uses radio antenna to communicate with the astronomers on Earth. The Hubble Space Telescope photographs objects near the edge of the visible universe, including distant galaxies containing billions of stars. Categorizing galaxies. A galaxy is an enormous collection of stars, dust, gases, and planets. Scientists categorize galaxies for the same reason they categorize stars and planets. If we can find out how galaxies are alike and different, we can better understand how galaxies work and how they form. One way to categorize galaxies is by shape: elliptical, spiral, barreled spiral, Baird spiral, and irregular. Elliptical galaxies are shaped like a ball or an egg. These galaxies may be large or small. They contain mostly old red stars and a little dust and gas. Spiral galaxies, like our own Milky Way, are shaped like disks. Spiral galaxies bulge in the middle and have luminous spiral arms. They usually contain plenty of gases to form new stars. Barreled spiral galaxies resemble spiral galaxies, but they have a straight bar of stars across the middle with arms curling out of each end. Scientists believe that new stars are born in the bars of these galaxies. Irregular galaxies have no set shape and are rich in gas and dust. They are usually the smallest galaxies, with many young stars and bright gas clouds where stars are forming. Two galaxies near the Milky Way, the large Magellanic Cloud and the small Magellanic Cloud, are irregular galaxies. They orbit the Milky Way, taking more than 1 billion stars to travel once around it. Taking more than 1 billion years to travel once around it. Gravity holds these two galaxies in place, but it is also working to pull apart the small Magellanic Cloud. Eventually, the smaller galaxy's stars will probably be pulled into our own Milky Way. The Magellanic Clouds are visible only from the southern hemisphere. Groups of galaxies. Gravity keeps galaxies together in groups and clusters. These clusters also form bigger groups called superclusters. At present, astronomers have identified more than 50 superclusters. Each one contains thousands of galaxies spreading over distances that would take a beam of light tens of millions of years to cross. The Milky Way and Andromeda Galaxy and a few smaller galaxies, including the Magellanic Clouds, form what is known as the local group. How close together are the members of our local group? The Andromeda Galaxy is about 2.25 million light years from the Milky Way. The Magellanic Clouds are much closer, just about 200,000 light years away. Galactic surprises. Scientists use many different tools, including radio and infrared telescopes, to explore the Milky Way. Near the center of our galaxy, scientists have found extreme temperatures, star motions, and disturbances. These discoveries have led astronomers to believe there must be a black hole in the core of the Milky Way. That is 2.5 million times more massive than the Sun. Some distant galaxies, called active galaxies, also seem to give off more energy than expected. The most powerful kind of active galaxy is called a quasar. First discovered in 1963, quasars seem to be quite small and far away but emitted huge quantities of energy. Scientists now believe they are the core of galaxies many billions of light years from Earth. The cores may have giant black holes that are absorbing huge quantities of matter, which would explain why so much energy is being released.